we have to solve for this notion of a data engine. They have 750,000 robots.
Most people would found a company that saves 500,000 lives and maybe call it done, but you're not. Now you're working on the next thing. What makes you tick?
I thought I would make an impact by building a device. And the way we're going about it is slightly unconventional. And this has come from sort of the school of hard knocks.
What's been the hardest technical challenge you guys have solved to date?
That's what these foundation models that we're building are trying to build at their core. It's essentially a model of the world that the robot can query.
We're here in San Jose at the HQ of Electric Sheep Robotics with CEO and co-founder Nag, and your buddy over here. Who is this?
That's Verdie. It's like a sort of proof of concept embodied AI agent that we're working on in the stealth. Well, no longer in the stealth, now in the video.
If you can't see this, you're listening to this. There is Verdie, the name, because I believe green is a part of it, is self-balancing, running with just powered tether from what I see, just doing circles in fully run as an AI agent, which is incredible.
Yep.
We talked about it a lot in the episode, which we just wrapped up filming, but can you talk to me a little bit about your guys' approach and how you're doing things differently for trying to create very real-world use case application robots?
Yeah. So Electric Sheep Robotics, our core mission is we want to build embodied AI agents that can transform outdoor work. And the way we're going about it is slightly unconventional as a company. And this has come from sort of the school of hard knocks, of like trying to scale like a traditional robotics company, and then we realized that, there's probably a better, more profitable way to do it.
Can you clarify what scaling like a traditional robotics company looks like and how you're doing it differently?
Yeah, that's a great question. So traditional robotics is all about RaaS. It's robotics as a service. And I think it's like a derivative pattern matched equivalent of like SaaS. So all the software VCs went like, ooh, SaaS, I'll just replace one letter and you have RaaS, solved it, right? That's really a terrible way to think about robotics, especially in the age of AI, because what robotics is a means for AI to break out of like the digital world and come into the physical world. Right? And for it to do that, it needs a business model that is tolerant of like the imperfections of machine learning. And that requires, air cover for when the robot makes mistakes. You almost want to think about like building an 80% good enough robot and then letting it learn within your own business till it becomes better and better over time. And weirdly enough, this is how Facebook has been building its models, right? They've built these internal AI models and they've improved internal to Facebook, right? They're not going to an external AI vendor and saying, sell me your AI agent. So why should robotics be any different?
Very well said. Can you talk more about the model you have of acquiring?
Yeah. So the way to solve, for embodied AI really we have to solve for this notion of a data engine. Because for OpenAI to go and build ChatGPT, they could just buy these data sets that were there in the web, right? They scrape data sets from the web, they scrape YouTube videos. But for robotics, the problem is one of having data from the vantage point and tied to the embodiment of the robot itself. And this does not exist in the real world today. So you just can't like watch hours of YouTube video and then magically have a robot do its thing. And so what we decided to do was we said we need to solve for the data engine first and then use that data to build, an increasingly sophisticated model. Put that model into simple machines, let them go out there and establish that feedback loop. When, when they make mistakes, you can sort of go to the cloud, retrain your model, and then redeploy robots. So our business model is all about buying companies for their data and for the employees that work there, because now they provide the reinforcement learning for our robots. So that's the RLHF part of robotics, which is really cool. So that's how we're different from other companies.
What led you to founding Electric Sheep in this manner?
So the intent was always to sort of build a full stack business, right? And this really comes back to where my co-founder comes from. He comes from the traditional landscaping industry, and he was part of these landscaping roll-ups like KKR and all these private equity players. They've been rolling up the landscaping industry for decades now, right? And they've been building these massive. So the biggest landscaping company, you'd be surprised to know, is something called Brightview, and they're publicly listed, right, on the stock exchange. Wow. So they do $3 billion in revenue, and nobody knows this, right, which is crazy. And when you think about landscape, you're thinking about two guys on a truck, right? That kind of a business, but it's a huge business. And so there's precedence for building, for rolling up these companies. But then when we started to look at like the promise of what robotics could do, we said the best unlock that robotics can provide is for a business to internalize it and improve its own margins. That's what led us to a full stack model at the end of the day.
What led you to specifically this idea of, I want to make electric robots that do landscaping? Like what personally led you to that idea or that?
So I grew up without any exposure to landscaping or even like grass for that matter, right? Like I grew up as a city dweller. I grew up in Bombay and then I've lived in cities all my life. What happened was after I exited my first company that was, it was a medical devices company. I was in the Bay Area for the longest time. Then I went to DC to work for the Obama administration. And in that process, I said, hey, I'm going to put down roots in DC. So I bought a house on the outskirts in Nova. And that was my first exposure to home ownership. And most houses in the East Coast have, a huge amount of lawn associated with them. And so that was the first time in my life I'd actually stared at like a ZTR or a push mower. I had no idea, how to take care of it. And then the engineer in me was like getting bored. Like I want to think about, okay, I got to start another company sometime. And so let's mess around with these things and see if we can make them move. And it turns out that it's not something novel. People have been building lawn mowing robots. That's really not where the interesting part is. Nobody's thought about solving it end to end and solving for the really hard cases of like embodied intelligence that can wield a machine the same way a human can, with the same level of fluidity and reliability that a human can today. And that was the impetus to start Electric Sheep. And the name comes from, Philip K. Dick's famous book, which is Do Androids Dream of Electric Sheep? It's also a play on grass because sheep eat grass.
Grass is a service, or I guess landscaping is a service.
Grass eating is a service.
Yes. Can you tell me a little bit about the first company you built and what you learned from that experience?
Yeah, so the first company was like a work of passion. So when I went to grad school here at Stanford, and I took a class called Design for Extreme Affordability, where they exposed us to this notion of public health inequity in all across the globe. And so the problem posed to us in the class was there are, millions of low birth weight and premature babies that are dying of lack of access to adequate health care, and more specifically, warmth. And this is true in all kinds of war zones, as well as developing countries, right? Refugee camps. And so the problem posed to us was, can you come up with like an infant warmer or an incubator that can keep these babies alive without electricity in harsh environments? And so that sort of ignited a passion to build something, right? Because I was like, I really want to solve this problem. And so we started a company out of grad school. And, we grew that to a scale where now it's saved over like 500,000 lives across 22 countries. So it was an awesome experience, just learning how to scale that. It was hard tech, because it's med tech. You have to go through regulatory approvals, learn a ton about building life-saving equipment. So it was a great journey. And most recently, I learned that, they're being deployed in Ukraine in the war, which in the bomb shelters. So pretty cool, story right there, to look back on and apply those learnings to something like robotics at the end of the day.
Most people, I think, would found a company and exit it that saves 500,000 lives and maybe call it done. Yeah. But they're like, okay, I've done my duty. I'm gonna maybe retire. But you're not. Now you're working on the next thing. What makes you tick? What inspires you and motivates you?
I really want to solve this problem. I think so. What changed for me personally was reading Ray Kurzweil's book, that the singularity is near. It just blew my mind. Like it just changed the whole worldview that I had. So when I started Embrace, which was my previous company, I thought I would make an impact by building a device for, to impact a health condition. But then when I read Kurzweil's book, this notion of AI and AGI, right? It makes you think as an engineer that that's the only thing worthwhile that you want to focus on at the end of the day. And so getting into this company was really about like, how do you accelerate like our progress towards building embodied AI, and we can make one small contribution to sort of this, all the like, streams of work that are building up towards the singularity. And so really this is probably the only thing worth working on right now, right? Like just contributing to how singularity can come about.
I think a lot of people, when they think of super advanced AI or the concept of singularity, get pretty scared. Where it's because it's unclear. Yeah. In your mind, you seem excited about it and not so worried as much. How do you think about it?
I think it comes from, so one, I think fear, like the FUD is like overblown because, I mean, you work with robots or hardware, you realize how difficult it is to get the damn thing to even do what you want it to do.
This one's taking a break. He's on his lunch break. He's tired.
He's chilling out. And the thing is, you just realize that comes from a place of not knowing what true problem solving is in the hardware, in the hard tech space. And so having built a hard tech company before, I really feel like this is overblown, right? And second, I think you'll always have a world where humans will co-evolve with these machines and almost teach them as they grow. So we don't think humanoids are here to take over the world. We believe in more simple animal-like intelligence, that can sort of cat GPT, if you want to call it that. That can
I like that a lot.
Like that can like help humans do what they do better. And then lastly, I think you need to accelerate towards an age of abundance, because I've traveled the world. In the US, we're very fortunate, like with all the abundance we have, but we don't realize that 90% of humanity does not live like that, right? So it really behooves us as engineers and creators to sort of unleash that radical abundance for everyone. And so it's the only thing worth doing at the end of the day. So I'm looking forward to it.
What a great answer. How do you, in your mind, think about inspiring people to also work on meaningful problems and to unleash abundance, as you say?
I think they should read these books, right? Like what Kurzweil has written, and look at. I think there's another book that I read on nanotechnology and how you could literally print, your own food, solve world hunger that way. So I think we're entering the age of hard tech, right? And this is so exciting. The next 20, 30 years, it's going to be mind blowing.
I think a lot of
no sass.
No sass. So I think a lot of what I see on online and social media and culture can be very negative, especially on everything. But part of everything is tech.
Yeah.
And what do you think kind of causes that? What do you think the solution is to that?
I think people just should get out there and build. Passive consumption just leads to all kinds of crazy thoughts in your head. It's better to go out there and make a positive contribution by building something or creating something.
You talked a little bit about nanotechnology and the idea of the singularity. What technologies and research in the next 5 to 10, 15 years have you the most excited?
I think it's the robotics, obviously. Cognitive work is very close to being, solved for. Although I think there's the problem of agency, which now OpenAI is squarely focused on. How they get the data and the data feedback loops to solve that still is an open question. We think we need a full stack model to solve those problems in robotics. So that's what has us excited. Outside of that, I've not caught up with healthcare for a while now. So but from what I've sort of read recently, it really comes down to the CRISPR technology is taking off in a big way, right? So I'd say there's progress we're going to make on all fronts, but I'm just tunnel vision on robotics right now. And that's all I know.
What's been the hardest technical challenge that you guys have solved to date, and how did you engineer out of it?
I think it's the business model challenge. Robotics is not, there is no technical breakthrough that we need to make as much as it's a data profitability breakthrough when it comes to solving for robotics. Because you don't need an algorithmic breakthrough at this point. Right? You've got all you need to build fairly capable robots. Maybe one would argue that language models aren't capable of reasoning and planning. So there's still a breakthrough needed there, right? There's a different system kind of thinking that's needed to do planning and reasoning. But for our use case, you don't really need extreme levels of cognition. You need animal level intelligence, so we have everything we need. So for us, the biggest unlock has come from finding a way to profitably scale the data acquisition engine, which is by buying companies and by building this data engine. So it's really a business model problem, not a technical problem in robotics.
It is interesting how it kind of comes back to this interesting data compute layer often with these really hyper advanced technologies. Like this weekend of filming was the weekend of the meme of Sam Altman trying to raise $7 trillion and everyone's either trying to get more GPUs, more compute, or more data to train these agents. Do you think we'll see any fundamental shifts? I don't know. To me, this reminds me a lot of the way early days we were trying to make bigger and bigger computers with vacuum tubes until eventually things got smaller and the transistor was sort of invented versus this idea of a binary switch. Do you think there'll be anything like that, or do you think it really is just like a brute force problem of more compute, more data?
I think it's just brute force. It depends on what level of agency you want, right? So if you're really talking about very complex human-like agents, then I think maybe there's another breakthrough needed. I don't know. Like I'm not like an expert in that domain. But when it comes to robotics and very simple tasks, I think it's just brute force data. I would not say it's compute as much because robotics is edge constrained, right? So it's really data and data feedback loops. And Tesla has done this really well, right? Because they have like sold all these cars and now people are paying them for the privilege of testing their cars, which is pretty wild if you think about it. And I think that's what robotics needs as well. It's just data and like you'll discover the scaling laws as you deploy more and more robots.
What do you think most hard tech startups get wrong?
Business model.
Really?
Yeah. And there's a lot of complicated reasoning behind it because I think that the capital allocators, have sort of communicated a certain worldview to their LPs on what ought to how traditional businesses ought to look. But take robotics, for instance. Who is the world's largest deployer of robots? Amazon, Tesla, by any stretch of the imagination. They're all full stack businesses, right? They're not like a robotics company going and selling. So it comes down to business models. And maybe all of hard tech I'm generalizing. I'm just talking about robotics here because I have no idea what a space company does or anything else.
Well, it's interesting though. I think you're right in that most of these best performers in multiple classes, whether it's robotics, engineering, production, are the best in class at every stage of their niche of that full stack problem. Like Tesla has gone from 0 to 1 and making cars incredibly well. Amazon has built the world's most impressive consumer goods fulfillment system. That's a very interesting insight.
They have 750,000 robots.
Through Kiva?
They initially bought Kiva, but then they in-housed all of it. And then they just kept on making it better and better.
This next question's a little weird.
Yeah.
But how do you think? Can you try to describe how you think? Either when your brain comes across a problem, how does your brain kind of react to it? Or what are some mental models and lenses you commonly find yourself looking at the world through?
I think I'm hugely influenced by the whole notion of first principles thinking. So you really want to ask yourselves why are systems the way they are, and then make attempts to make small attempts to solve the problem to understand why you might either be right or delusional, and quickly course correct. And so that's really, those are sort of the two approaches. Maybe one's like the first principles approach and the other is like a rapid prototyping approach to either proving or disproving yourself.
What's something you wished more people asked you about the company?
Why full stack, right? And why embodied AI? Why not classical robotics? Because there's a huge difference between the two approaches. And it's very clear embodied AI is going to be the way to scale, these classes of robots.
Just because the terrains and offerabilities are so different, or because...
Yeah, it's very different. So, for the first 2 years, we were doing classical robots. So what we do is we, take that big machine out there and we'd map out an entire property, right? And then you'd have to teach it like a path within that property. And it'd go back and forth trying to cover the property. But then you realize that you're really asking unsophisticated, untrained operators to go do this every time out there, right? What happens when the environment changes, right? When the leaves fall off the tree, like your visual slam goes for a toss, right? And so you quickly realize that the best path to doing this is by imbuing the machines with a sense of common sense, right? Which is what, this ES1 foundation model that we're building does. And it's a very sort of react to its environment sort of robot. And so what's cool about what we have right now is there's no app. There is nothing but an on-off button on the robot. That's it. You can go to any site, anywhere on Earth, put it down, and it's off. It can go in 30 seconds. Because it's just, it's like a thinking machine. It like has a sense for like what's around it.
Can you talk about, a lot of focus has been put into sort of an attempt to make general reasoning AI with LLMs or foundational models. But I think the most interesting and least talked about or approached model that's being built are physical-based models. Right. I don't even know like the right questions to ask about this. Like, what has your experience been thus far developing ES1 for this?
It has to do with, so there's cognitive tasks where you require a lot of verbal reasoning. And that's what LLMs are somewhat good at, although they're not really still good at planning and, maybe they're good at retrieval, but it's not quite sure if they're good at reasoning and planning, right? Or if they're just sort of retrieving similar pattern. That's there. When it comes to physical world intelligence, again, like going back to ChatGPT, it's like the cat is the perfect animal to study, right? Like you've seen
as a cat guy, I love this. This is great.
It's incredible, right? Like you've seen them like navigate dominoes, like people have laid out on the floor, and they have this incredible sense of proprioception on where exactly they need to place their feet, what's around them, and that is a form of intelligence, and that's spatial intelligence, that's physical intelligence, right? And that's what robots need at their core. How do you safely navigate? How do you efficiently navigate from one place to another? How do you get a task done in a way that is commonsensical, right? And so what that comes down to is, do you have a world model? Do you have a model of the world that you can reference when planning or thinking about what to do with a task? And that's what these foundation models that we're building are trying to build at their core. It's essentially a model of the world that the robot can query to say, what happens if I do this, right? What happens if I drop this or what? And so when you develop that, that's the common sense that you need to execute all manner of tasks. So the world model is task agnostic. So that's your physical intelligence. And you can take that world model and then you can apply it to various kinds of tasks like mowing the grass or, trimming or blowing away leaves. And there you have to train it on knowledge that's specific to the task. But all of these tasks still require an innate physical intelligence about the world, right? Like what happens if I blow a leaf? It's going to rise up and go. So that intuition is task agnostic, and that's what we're building. And then you train it on task-specific policies like mowing and trimming and blowing.
Is much of the model training you've been doing kind of pulling some open source libraries? Has it just all been about, like, when you say the physical world in this model space, what does that mean?
Yeah, it's a great question. So what we're fundamentally doing is called model-based RL, right? And there's precedence to how this is done. Our variation of it basically involves like two steps, right? One, we pre-train in simulation. So much like ChatGPT pre-train on large corpus of text, we build these large virtual worlds in simulation. We use NVIDIA Isaac, and then we let the robot sort of run wild and discover, the laws that it has to discover. Like I shouldn't go over a curb. If I do, I'll come back and I'll retry again. I'll teach myself what's grass, what's not grass, and then you'll procedurally vary the simulation, right, to keep confusing the robot so that it keeps learning, right, new scenarios. And then that way you get an 80% good enough model, similar to the base model that you get when you pre-train, when you're building a large language model. Then you put the pre-trained model on the robot, and then you let it so we've got a fleet of robots that's across thousands of sites right now. And so these robots, when they go out there, they will run into issues, right? So I'll give you an example. They can't deal with sun glare, or they couldn't deal with sun glare. And so the sun glare then gets logged, and then when the robot uploads the data to the cloud, you now have a bunch of images you can use to fine-tune your base model, right? So that's your data engine in play. And now the fine-tuning now helps your model improve to now account for sun glare, right? And similarly, you can do it with tree roots, right? Or like really wacky curbs, like where you can't see the edge of the curb and then now suddenly you fall off the curb, right? And so you can't cover all that in simulation, but then the data you collect is not only used to improve the base model, it's also used to improve your simulation itself. So it does both those things. And so that's kind of like our internal process to how we're building this model.
What's the biggest thing you learned since founding Electric Sheep?
Again, go back to like, this is a data problem, and this is a business model problem, and robots are not going to happen suddenly. Like you're not going to see like a hockey stick curve, right? You're going to see like a model is going to improve, and suddenly there's going to be a breakout moment, but that curve is not, I don't know what it looks like, but it's certainly not like a typical product curve, right? So that's been the biggest learning, and that's kind of like why we built the company we built.
My last question,
Yeah.
What is your current life philosophy?
Well,
Well, a little bit of an easy one.
honestly, I don't have one. Like I'm like just focused on building the company, make the company grow.
Nag, thank you again
Yeah.
for having me here and for building Electric Sheep Robotics.
Yeah, no, thanks for coming over. It was awesome chatting with you guys and showing you guys what we're doing. So.
We did it. Awesome, man. Thank you.
Yeah.
This is great.